Okay, so up till now we have discussed how to calculate the depth of watering or how to calculate the root zone depth of soil. And now we are discussing about how to calculate the frequency of irrigation. So I hope this is clear to you. Okay, once again I will repeat field capacity. Field capacity is the moisture content, is the upper limit of the available moisture content. It is also upper limit of readily available moisture content. And M0 is lower limit of readily available moisture. Readily available moisture content is taken as 75 to 80% of available moisture content. And available moisture content is worked out as FC Hg into D into bracket FC minus Wc. Whereas if we have to consider readily available water content, and from that, if we have to calculate the depth of water applied for each watering, then formula will be dW is equal to gamma D upon gamma W into D into bracket FC minus M0, and the answer will be in meters. Okay, this FC and M0, they are fractions. Root zone depth D is in meters, and that's why it is in meters. And CU is a daily consumptive use rate of crop. So if we divide the depth of water applied for each watering with number of with daily consumptive use, we get to know what is the frequency of watering required. Okay. So now we will see problems based on this. Okay. Before that, also we can calculate the time required to irrigate a certain area. Okay. So time required to irrigate certain area is denoted by T, and A is area of the field, and if Q is the discharge in the field. In that case, the time required to irrigate the area is T is equal to A into dW. A म्हणजे काय? Area of the field. dW काय? It is the depth of watering. And Q is what? Q is the discharge in the field. Okay. So in that case, we get answer for T in seconds, because area will be in meter square, depth of watering will be in meter, and discharge will be in meter cube per second. So meter square into meter upon meter cube per second. So the resulting answer will be in second. Now, if this area A is given in hectares, okay, in that case, the formula is P is equal to dW upon Q. Okay, this is dW and Q. And area is given in hectares, that's why it is multiplied with 10 raised to 4, so that the area will be in square meters. We know that 1 hectare is equal to 10,000 square meter. So that's why here it is necessary to multiply area in hectare with 10 raised to 4, so that we get answer for T in seconds. Now, if we have to calculate the same answer in hours, so in that case, the formula is 2.778 into A into dW upon Q. Okay, so A into dW upon Q is same, and 2.778 is a conversion factor. Okay, so it is a conversion factor. Now, after studying this particular formula to calculate time required to irrigate certain areas, now we will discuss about one example based on. Okay, so the question is, after how many days will you supply water to the soil? The type of soil mentioned is a clay loam, in order to ensure efficient irrigation of given crop. After how many days means what we have to calculate? Frequency of irrigation. Okay, so for that, data given as field capacity is given as 27%. Field capacity is 27%. Then permanent wilting point or wilting coefficient is given as 14%. Okay. We know, if we know what is wilting coefficient and what is field capacity, so difference between these two is called as a available moisture. Okay. So field capacity is 27% and wilting coefficient is a 14%. So 27 minus 14. So that will be the available moisture. Okay. So available moisture, here it is worked out. Field capacity minus permanent wilting point, which is also known as a wilting coefficient, that is equal to these two values, 27% field capacity, wilting coefficient 14%. So available moisture is 13%. Then we have learned that readily available moisture, okay, is generally taken as 75 to 80% of available moisture. So let us take that readily available moisture as 80% of available moisture. Available moisture is 13%. So 80% of 13%. So readily available moisture is 10.4%. Okay. So that can be easily extracted by the plant, and this will result in higher growth of crop and higher yield. Now we have to calculate what is the lower limit of moisture content in case of readily available moisture. Okay, now see this particular graph again. So FC minus WC. So this particular difference is called as available moisture. Then 80% of that is readily available moisture. आता आपल्याला काय करायचं की we have to calculate what is the lower limit of readily available moisture. So how to find this? We know that the field capacity is 27. And we know that the lower limit of the, we know that the readily available moisture is 10.4%. So if we subtract this readily available moisture from field capacity, then we get this lower limit of readily available moisture. So 27 minus 10.4, that is equal to 16.6% is the lower limit of readily available moisture. And now we know the formula to calculate dW. It is gamma D upon gamma W into D into FC minus lower limit of readily available moisture. So here FC is 27% and this is M0 is 16.6%. Both values are expressed in a ratio. Then here dry density of soil is given as 15 kiloton per meter cube. So here gamma D upon gamma W. So if we put all these values, then we get the value of dW as 119 millimeters, 119 centimeters or 0.119 meters. So by calculation, we get this as a dW. Now we know that formula for frequency of irrigation is what? It is dW upon Cu. dW is 11.9 centimeter and Cu is mentioned in the problem. Daily consumptive use of water for given crop. It is 11 mm. So 11 mm is converted into centimeters as dW. We have it is converted into centimeters, and dW, which is in meters, it is also converted into centimeters. So 119 centimeters upon Cu 1.1 centimeter. So frequency of irrigation is worked out as 10.82 days. But if this is a fractional value, in that case, we have to go for the lower value. So frequency of irrigation should be 10 days, not 11 days. Okay. So this is how we can calculate the frequency of irrigation. Okay. So what is the important point in this problem? That is readily available moisture. Readily available moisture is taken as 75 to 80%. You can assume any value or value may be mentioned in the problem. 75 to 80% of available moisture. So from that, what we get? Readily available moisture. If we subtract this from the field capacity, we came to know about lower limit of readily available moisture, which is denoted by M0. And when M0 is worked out, then we can calculate dW easily. And based on the daily consumptive use, we can calculate the frequency of watering. So such a problem may be asked in the exam. Calculate frequency of water. Okay. After this, now we are going to discuss about principal crops and crop seeds. So based on this, a short note may be asked. Okay, our question may be explain principal crops and crop seasons in India. So what you have to write? You have to write the classification of crops and crop seasons. Let us start with the classification of crops. So there are three classifications of crops. One is according to agricultural type, second is according to crop season, and third is according to irrigation requirement. Now, first classification is according to agricultural type. So according to agricultural type, the crops may be classified as a field crops. And the examples of field crops are wheat, rice, maize, barley, oats, great millets, spike millets, gram, and pulses. So you are familiar with wheat, rice, maize, manje maka. Okay, then you are familiar with the barley and oats. Great millets and spiked millets. या है जवार and bajri. Okay, gram म्हणजे हरभरा, pulses म्हणजे डाळ. So these are the examples of field crops. So next example. Next classification is commercial crops. So commercial crops like sugarcane, cotton, tobacco, sugar beet. Sugar beet म्हणजे रताळ. Oil seed crops. So the crops from which the oil is prepared. So example are groundnut, mustard oil, sesame oil, castor oil, and linseed oil. Linseed म्हणजे कापसा. Next is the horticultural crop. So horticultural crops are fruit crops, vegetable crops, and flower crops. Next classification is plantation crop. Okay, for which plantation is done. So tea, coffee, cocoa, coconut, and rubber, these are called as the plantation crops. Forage crops. Forage crops are the crops which are needed for feeding the animals, and examples are grass and fodder. And miscellaneous crops, which does not fall under above categories. So they are called as the medicinal plants, aromatic crops, and sericulture crops. And one more category is there, that is for the spices. Okay, masalacha sarva vanaspati. Okay. Next classification is based on crop season. Okay, so which are the major crop seasons in India? So major crop seasons are Rabi crops and Kharif crops. So Rabi crops are also known as the winter crops, for which the duration is in between October to March. And the crops which are taken in this duration are gram, wheat, barley, peas, mustard, tobacco, and potato. So the crops which are taken in the winter season approximately, so they are called as the Rabi crops or winter crops. Kharif crops are the crops which are taken in monsoon season. That's why they are also known as the monsoon crops, for which the time period is in between June to October. An example of Kharif crops are rice, maize, spike millet, great millet, pulses, groundnut, etc. Then third classification is of crop season is the perennial crops. So perennial crops are the crops which needs a continuous watering throughout the year. So examples are sugarcane, fruits, and vegetables which can be grown in any season, either Rabi or Kharif season or maybe in summer season. So this is a classification based on the crop season. Okay, one more classification is there, 8 months crop. So duration of the crop period is 8 months. So cotton is the example. Now third classification of crop is based on irrigation water requirement. So based on irrigation water requirement, crops are classified as either dry crops, wet crops, or garden. Now, what do you mean by dry crops? Dry crops are the crops which are taken in monsoon season and which does not need irrigation water. These crops are grown on natural rainfall, so they are called as the dry crops. Wet crops are the crops which needs the time to time watering. They are called as the wet crops. And garden crops are the crops which needs frequent watering. These are called as the garden crops. There is a term crop ratio. So what is the ratio? Crop ratio. It is the ratio of area irrigated in Rabi season to the area irrigated in Kharif season. So how much area is irrigated in Rabi season divided by how much area is irrigated in Kharif season. That ratio is called as the crop ratio. Then there is a term overlap allowance. What is overlap allowance? The crops of some season may overlap some period of next crop season. So that is called as a overlap allowance. So when such an overlap takes place, the crops of both seasons require water simultaneously. So this overlap allowance need to be considered while calculating the crop water requirement. Okay, and this is the table which shows the principal crops in India. Okay, it shows the type of crop. Okay, it's sowing time and harvesting time, and average delta means total depth of water required to be applied for a particular crop. For example, in Kharif crop, if we take example of rice, then sowing time is in June or July, and harvesting time is in between October to November. So depend on variety of that rice crop. This difference in crop period is there. And the average delta, that is the total depth of water required for full growth of crop, is 120 centimeter. And if we see this table, then it is highest. So rice required the highest quantity of irrigation. Now, in case of the pulses, okay, the what is average delta? Average delta is 30 centimeters. So for pulses, it is a minimum requirement. Same thing is about gram. Gram म्हणजे काय तर हरभरा. So it is a Rabi crop, which is sowing time is in between September, October, and harvesting time is in between March and April, and average depth of water required to be applied is 30 centimeters. And if we consider the last crop, that is sugar cane. So see, for sugar cane, the sowing time is in between February to March, and harvesting time is in between December to March. So here this sugar cane needs the 12 months of watering. That's why it is called as a perennial crop. And this needs the average delta of 90 days, 90 centimeters. If we take example of 8 months crop, it is a cotton for which sowing time is in between May and June, and harvesting time is in between December to April. So water applied here, total water applied here is 45 centimeters. So this is about principal crops in India. And now the next term we are going to learn is about duty and delta. Okay, duty and delta. So what is duty? The term duty means the area of the land that can be irrigated with unit volume of irrigation. Now, what is unit volume? Unit volume is 1 cubic meter per second. So, if 1 cubic meter per second of water is supplied to a particular crop during its crop period, then how much area it will irrigate. So that is called as a duty. Okay. So once again, see what is the definition for the term duty. It is the area of the land that can be irrigated with unit volume of irrigation water. So in other words, we can say duty represents the irrigation capacity of unit volume. It is the relation between the area of crop irrigated and the quantity of irrigation water required during the entire period of growth of that. So consider one example. If 3 cumecs of water is supplied for a crop which is sown in area of 5,100 hectares, the duty of irrigation water will be 5,100 divided by 3, that is 1,700 hectares per cumex. So this is one way to express the duty. What is the unit of duty? It is hectares per cumex. Okay, 1,700 hectares per cumex is example of one duty. Okay, and here the discharge of 3 cumex is required continuously throughout the base period. Base period म्हणजे काय? It is the time taken from first watering to last watering. So this continuous discharge is required. Then only it is possible to irrigate the total area of 5,100 hectares meter. Okay, so this is about the term duty. Second term is delta. What is delta? It is a total depth of water required by a crop during entire period the crop is in the field, and it is denoted by symbol delta. So this is a symbol used for delta. Okay, duty is denoted by capital D. Now here to explain delta in more detail, consider this example. Suppose a crop requires about 12 watering, okay, at an interval of 10 days. What is 10 days value? 10 days is the frequency of irrigation. Okay, and number of waterings are 12. And what is DW? A water depth of 10 centimeters. That is called as a DW. Okay, just now we have solved problems on calculation of frequency of watering, calculation of depth of water for each watering. So depth of water for each watering is 10 centimeters. And such a 12 number of waterings are required. So see here at the top. Okay, how to calculate the delta. Okay, so depth of each watering is 10 centimeter and such a 12 waterings are required. Okay, so what is the total depth of water applied? 120 centimeters or 1.2 meter. So this is delta. It is the total depth of water required by a crop during the entire period of crop. Okay, so this is about the term delta and duty. Now, up till now, many times we have used the term crop period and base period. So what is crop period? Crop period is the time in days that a crop takes from the instant of its sowing to that of harvest. From sowing to harvesting is crop period. And what is base period? Base period is first watering and last watering. So that first watering may be issued for preparation of ground. It may not be for actual crops, but before sowing crops, the first watering may be applied. So the term base period of a crop refers to the whole period of cultivation from the time when irrigation water is first issued, maybe for preparation of the ground, for planting the crop, and to its last watering before harvest. That is the base period. And crop period is different. It is the time required from sowing to harvest. Okay. So these are the two terms, crop period and base period. Okay. Now we are going to discuss about the term reckoning the duty. There are various ways of reckoning the duty. Reckoning the duty means expressing the duty. We have discussed the how to express the runoff. Runoff कसा express केला जातो? In terms of volume of water, in terms of centimeter sheet of water over the catchment area, and it may be in terms of discharge. In the same way, this duty can be expressed by following ways. What is the first way? Okay, reckoning of duty is possible by 4 ways. In that, the first way of reckoning the duty is by the number of hectares that 1 cumex of water can be irrigated during the base period. 1 cubic meter per second water जर supply केलं base period मध्ये तर किती area irrigate. So example is, okay, just now we have discussed this example, 1700 hectares per cumex. So that is the first way of reckoning the duty. The duty can also be mentioned in terms of delta. The second way is duty can be mentioned in terms of delta by total depth of water. In previous example, we have discussed about how to calculate the total depth of water. How we have calculated total depth of water or delta, that is equal to depth of water applied in each watering, that is dW, into number of such watering. So in the previous case, depth of watering was 12 centimeters and number of such watering was 10, and that's why this value of delta was 120 centimeter or 1.2 meter. Okay, so this is the second way of expressing the duty or reckoning the duty. Now, third way of reckoning the duty is number of hectares. Here, number of hectares that can be irrigated by million cubic meter of stored water. Okay, so what is this third way of reckoning duty? Consider 1 million cubic meter of irrigation water. So how much area it will irrigate? So this is how the duty is expressed. So here I have written the example of third way of reckoning the duty. Okay, so what is that way? 2000 hectare area can be irrigated from 1 million cubic meter of water. So this particular system of reckoning the duty is used in case of tank irrigation. So if we know what is the volume of tank, then we came to know how much duty will be there. Then the fourth way of reckoning the duty is by the number of hectare meter expended per hectare irrigated area. By the number of hectare meter expended per hectare irrigated area. Now, what is meaning of this? Consider 1 hectare meter volume of water. Now, you are familiar with the unit meter cube. Okay. Now here the volume is expressed in hectare meter. It is 1 hectare meter. See here it is written at the base 1 hectare meter. So 1 hectare meter can be converted into meter cube. So how to convert 1 hectare meter into 10 raised to 4? So now the volume is in meter cube. So 1 hectare meter, this is the meaning of 1 hectare meter. This is a quantity of water. So how much area it will irrigate? Suppose 1 hectare meter will irrigate 100 hectares area. So how the duty is expressed? 1 hectare meter for 100 hectares for 1 hectare. This is how the duty is expressed. So these are 4 ways of reckoning the duty. So based on this, question may be asked, what is duty and delta, and explain the ways of reckoning duty. So along with this example, you have to write these 4 ways of reckoning the duty. Okay. One more question will be asked on this. Derive a relation between duty, delta, and base period. Okay, now we are going to discuss about that relation. Okay, before that, let us know about how the duty changes with its place of measurement. How the duty changes with its place of measurement. At first, carefully observe this figure. What we can see here, there is a main canal which supplies water to the distributory. This is the main canal. This water supplies to the distributory. Distributory supplies this water to the water course. And assume that through the water course, water reaches to the field at point C. And suppose the duty at point C is 1700 hectares per cubic meters. But if we measure the same duty at B, this duty may be 1545 hectares per cubic. Now, why this duty is decreased? It is due to the conveyance loss. Okay, here I have written CL. CL means conveyance losses. So suppose this conveyance losses is 1 cumex. So instead of supplying 1 cumex at point B, the water supplied should be 1.1. Similarly, if we have to find out what is the duty at the A, we have to consider what is the conveyance losses in between point A and B. Suppose the conveyance losses are 0.2 cumex. So the water supplied at A should be 1.3 cumex, so that water will reach up to point C as 1 cumex, and in that case the duty will be 1700 hectares per cumex. So likewise, the duty changes with place of its measurement, and it is due to the conveyance loss. Okay. Next point is types of duty. So which are the types of duty? So first is a gross duty. So the duty measured at point A is called as a gross duty, which is measured at the head of the canal. Second is a lateral duty, which is measured at the head of the branch canal. Next is outlet factor. So it is the duty measured at the outlet of the canal. And the net duty is the duty measured at the head of the land to be irrigated. Okay, that is point C. The net duty is duty at point C. Gross duty is duty at point A. Lateral duty is duty at point B. Okay, so these are the types of duty. Okay, and now we will see what is the relation between duty, delta, and base period. And by making use of this relation, it is possible to find out what will be the crop water requirement. Okay, so for that, let us capital D be the duty expressed in hectares per cube. Delta is total depth of water supplied in meters. And let us capital B be the base period in days. What is base period? It is the time required from first watering to last watering. Next is, now we are going to derive a relation. So if field area is d hectares, assume that the field area is d hectares. Water supplied to the field, from this we have to find what is water supplied to the field if the total depth of water applied is delta. Okay, so total depth of water applied is delta, and D is what? It is a field area in hectare. So area into depth of water, that becomes volume, and that volume will be in hectare meter, because D is in hectares and delta is in meters. That's why the water supplied to the field is in hectare meters. Now let us convert this into cubic meters. We know that 1 hectare is equal to 10 raised to 4 cubic meter. So convert hectares into square meter, and delta is in meters. So D is multiplied with 10 raised to 4. So as to convert D from hectares to meters. And delta is in meters. So that now the volume of water supplied to the field will be in cubic meter. That is D into 10 raised to 4 delta. Now consider second equation. Here, if the field area is D hectare, similar to previous case, and assume that 1 cumex of water is supplied during the base field. Okay, field area is D hectares and 1 cubic meter of water is supplied for the base period. Now again, similar to previous case, let us calculate water supplied to the field. Okay, so in the second case now, water supplied to the field will be 1 cumex, 1 meter cube per second for the base period. The base period is in number of days. So let us convert this into seconds. Okay, the time should be converted into seconds. B is in number of days. This discharge is in meter cube per second. So this B should also be in seconds. Okay, so that the resulting volume will be in meter cube. So this base period B, which is in days, that is converted into seconds by multiplying this with 24 into 60 into 6. Number of days into 24, it will be number of hours into 60 in minutes into 60 in seconds. So likewise, ultimately we get water supplied to the field in meter cube. And what is that value? It is B into 24 into 60 into 60. Okay, into 1. Now, this is equation 1, D into 10 raised to 4 into delta. And equation 2 is what? It is B into 24 into 60 into 60. So these two equations are what? These are the water supplied to the field. So let us equate these two equations. First is D into 10 raised to 4 into delta. And second is B into 24 into 60 into 60. Now by solving this, okay, we can find out expression for either delta or D or B. Okay, so if we can find out expression for delta, then it is delta is equal to 8.64 into B by D meters. Delta means it is the total depth of water applied to the crops during its base period. So it is in meters. D is in hectares. D is in square meter. And B is base period, that is in terms of seconds. So we get delta is equal to 8.64 into B by D. So this is the relation between duty, delta, and base period. And using this relation, we have to solve problems on crop water requirement. So that we will see in tomorrow's lecture. In tomorrow's lecture, we will see how to calculate the crop water requirement using the relation between duty, delta, and base period, which is delta is equal to 8.64 into B by D. Okay, so with this, today we'll stop here as time is up. Thank you.